Okay, uh, look, the question says solve the differential equation 2y minus x is a power of y dy minus is a power of y dx is equal to 0. You know, a differential equation is nothing simple. It's an equation that contains the derivative of one or more dependent or unknown variable with respect to one or more independent or the known variables. You know, basically we have two types of differential equation, which are the ordinary differential equation and the partial differential equation. Actually, this one is the ordinary differential equation. So now let's try to see how we can solve such types of equation. You know, this is simply solved by using the exactness concepts, because here we have the dy, also here we have the dx. Now let us try to see how we can solve it. Solution. Now let us try to identify the m of xy and the n of xy. Usually m of xy is, you know, the coefficients of the dx, while n of xy is the coefficients of the dy. So now here m of xy is equal to this one, that's negative is the power of y, and n of xy is equal to 2y minus x is a power of y. Now let us find the partial derivative of m of xy with respect to y and the partial derivative of n of xy with respect to x. Look, actually here m sub y means the partial derivatives of m with respect to y, and n sub y means the partial derivative of n with respect to x. Actually, this differential equation is said to be exact if m sub y equal to n sub x, which means the partial derivative of m with respect to y equals to the partial derivative of n with respect to x. If it is if they are equal, simply we can say it's exact. If they are not, it's not exact. So here we are expected to find the integrating factors and then multiply both sides by integrating factors to convert, you know, those into exact. So now let's find the partial derivative of m with respect to y, or simply m sub y, which is equal to, you know, the partial derivative of is a power of y with respect to y, simply negative actually, which is equal to minus is a power of y, and n sub x. You know, here simply the partial derivative of 2y minus x is a power of y with respect to x. Look, you know, we can differentiate, you know, this one with respect to x. Here there is no x, so we cannot consider this one. Now let's differentiate this one, which is the partial derivative of x with respect to x is 1 multiplied by y, which is negative is a power of y, and the partial derivative of is a power of y with respect to x is 0, because here we can differentiate using x, you know it, which means simply differentiating this one with respect to x, it should be automatically is a power of y. Now here m sub y equal to what, you know, n sub x. The differential equation is exact. Exact. After checking whether the DE is exact or not, if it's exact, we have the solution, which can be expressed in the form of this one. That's u of x y is equal to the integral of m of xy dx plus g of y. This is our solution. Now here, this is our solution. Now here simply, which is equal to integral of what is m of xy? M of xy is this one, which is this one. No, that is negative e the power of y dx plus g of y. Look, you know, this one is simply constant because here we can differentiate with respect to x. Then now here we have negative is a power of y times the integral of dx plus g of y, which is equal to negative is a power of y times x, because the integral of dx is x, plus g of y. This is our solution. The solution. Now here we are expected to find g of y. Look, let us find g of y. G of y. Look, now the question is how we can find g of y. We have an interesting fact here, which is simply we can differentiate u of xy and this one with respect to y. Then the partial derivative of u of xy with respect to y is n of xy. Look, so now here the partial derivative of u with respect to y is equal to the partial derivative of this one, x times negative e the power of y plus with respect to y plus the g of y over the partial derivative of g of y with respect to y, which is g prime of y. Actually, this one is n of xy dy, which is equal to simply this one is the partial derivative of x times negative e the power of y with respect to y is nothing, simply the partial derivative of x with respect to y times the partial times is the power of times negative is the power of y plus the partial derivative of negative is the power of y with respect to y, plus what we have plus g of y over the partial the partial derivative of g of y over the partial derivative of g of y with respect to y, which means simply this one is plus what the prime of y. Now let's find this one. Let's find this one. So here this is actually 0, because partial derivative of x with respect to y is 0. Now let's do this one. The partial derivative of is a power of y with respect to y. This is what our concepts here. Actually, this one is 0. The whole should be 0. If we can derive only this one, simply we have this one. Look, negative x is a power of y. Simple. Now what's n of xy? N of xy is over there, I think. Where is? Yeah, look here. Twi 2y minus x is a power of y. Sorry, x is a power of y equal to minus x is a power of y plus g prime of y. This is cancelled by this one. Again, here g prime of y is equal to 2y. Now let us integrate both sides. That is g of y equal to integral of 2y dy, which is equal to sorry about the quality of camera. Actually, it's my phone. This is 1 over 2 y square plus certain constancy. Here we have 2 is cancelled by 2, which is equal to y square plus certain constancy. This is g of y. Now let us substitute in our solution here, because our solution is u of xy equal to negative x is a power of y plus g of y minus x is a power of y plus g of y is y square plus certain constancy. This is our solution. Now how we can find the general solution? A differential equation may have the general solution, particular solution. What else? Now the general solution is general solution is simply negative x is a power of y plus y squared is equal to certain constancy. This is simply, this one is arbitrary constant. So we can solve such types of question using this simple mechanism. Actually, if our differential equation is not exact, we are expected to find integrating factor. We have several methods of integrating factors. So by using those methods, we have to find integrating factors. Thank you for your watching. If you have comments, it's possible to write your comment on the space provided.